Let's solve a word problem from quadratic equations. Now this question is based on numbers. The difference of the squares of two natural numbers is 84. The square of the larger number is 25 times the smaller number. So find the numbers. Here there are two numbers, so we can start off by taking a variable for both the numbers. So let's say that the smaller number is x and the larger number is y. Then we'll translate the statement in English into mathematical equations with these variables x and y. So the first is that the difference of the squares of two natural numbers is 84. Difference of squares, um, so we have to assume that this is the larger number square minus the smaller number square, because the difference is positive, so the larger minus the smaller. Larger number is y, square of that is y square. So y square minus the square of the smaller number x square is equal to 84. This is the first statement. When we translate, we get this equation. Then the second statement is that the square of the larger number is 25 times the smaller number. Again, square of the larger number is y square, and this is equal to 25 times. So 25 multiplied by the smaller number, that is x. So we have y square equal to 25x. So these are the two equations when we translate the two statements. So we can do a substitution to get rid of one variable, so that overall we have an equation with only one variable, and we can solve that easily. So let's say that the y square equal to 25x, if I substitute in the first equation, the first equation will become 25x minus x square equals to 84. So this is a quadratic equation in one variable, and we know how to solve it. So let's say that we move all the terms on the right side. So then we'll have plus x square minus 25x plus 84 is equal to 0. This is the standard form of quadratic equation. Now from here, either we can factorize and solve it, or we can use the quadratic formula. Anything is fine. Let's try to factorize it. We have 1 into x square and the constant is 84. So we are looking at product of two numbers as 84, and the sum of the two numbers I want minus 25. So if I split 84, 84 can be split as 42 into 2, and 42 is 21 into 2. So if I take a look at a combination, I can see that 21 into 2 into 2, which is 4, can give me 84. I need the sum to be negative 25, product to be positive 84. So I can choose negative 21 and negative 4, so that the sum is minus 25 and the product is positive 84. So then the next step can be x square minus 21x minus 4x plus 84 equals to 0. So the minus 25x, the middle term, I can split it as minus 21x and minus 4x. Then take common factor from first two terms. We have x and we get x minus 21, and from the last two terms we can take minus 4, again x minus 21. So x minus 21 is common, and we are left with x minus 4 equal to 0. So product of these two things is 0. That means either one of them can be 0. Either x minus 21 equals to 0 or x minus 4 equals to 0, x equal to 21 or x equal to 4. Now both are positive numbers, both are natural numbers. My question specified that I am trying to find two natural numbers. So as of now, x, both the values are natural numbers. It seems like both are possible, but we need to look at the other number, which is y, and then we will decide what is possible. If x is 21, then we had an equation saying that y square equals to 25x. Let me use this. So y square will be equal to 25 into 21. That means y, if I take square root, will be 5 root 21. Now this is not a natural number. It becomes irrational, so it's not a natural number. So I cannot take x equal to 21. This is not possible. If I take x equal to 4, then again according to the equation y square equal to 25x, 25 into 4. So y will be equal to root of this, which will be 10. Now 10 is a natural number, so x equal to 4 and y equal to 10 is a valid combination. So I will say therefore the two natural numbers are 4 and 10. Now if I do a quick check, I will find that these combination of numbers 4 and 10 will definitely satisfy the original statement given, so it is the correct solution.